Hey guys, we're back. Our goal of this part of the lesson is to make sure that we can interpret a y-intercept and interpret a slope. So let's get going right away. What I have in front of you right now, right here, is I have the equation based off of our data from the weight of a mixer and the cost, okay? So our job, right, as statisticians is we want to be able to interpret what we've calculated. We're not just number crunchers. We tell that story behind the number. Let's get to it. What is a y-intercept? Go back to your algebra days. Hopefully you're thinking, hey, that's the point where the line crosses the y-axis. When x is equal to 0, that's the value of y on that line, right? There's my y-intercept, x is equal to 0. So what does that mean for our data here? Well, our x, right, our explanatory variable is the weight in pounds. So I can type that in real small right here. And our y, well, that was the cost of the mixer. So what we say then is we say, well, hey, when the weight of the mixer is 0 pounds, this is the cost of our mixer, because when x is equal to 0, this is the value of y. That's your y-intercept. Let's get that down as an actual definition or interpretation. So you have it in your notes and make sure you're pretty close to word for word. The College Board is looking for specifics on these, okay? Give me 1 second. Interpret the y-intercept. The model suggests, right? Because this is our model that we have created based off of our data. It's modeling what we believe is happening, okay? With the weight of the mixer and the price. The model suggests when blank is equal to 0, what are you going to put in there? You're going to put whatever the x variable is in context, okay? The predicted value of y, again, that needs to be in context, is approximately blank. What goes right here? This is the value of your y-intercept. Take a second, you guys, and write this down. Okay, now let's actually write it down in context for this problem we've been working on, okay? The model suggests when the weight of the mixer is 0, I should put pounds, right? The predicted price will be, ooh, spelling error, embarrassing. Approximately, right? So I'm following exactly what I have here. The model suggests, When x, okay, that's right here. Let's highlight it. When x equals 0, when the weight of the mixer equals 0 pounds, the predicted value of y, the predicted price, okay, will be approximately negative $20.711. There's the value of my y-intercept with its units, okay? Now, you'll notice there are some times in statistics, like this time, where it doesn't make sense in context. So then what we do is we add this second sentence here. This is only meaningful if a mixer is 0 pounds. There's another example where we look at the weight of babies, and I can't remember what the response variable is, but the y-intercept is when x is equal to 0. Well, the weight of a baby is not going to be 0. That's not meaningful. It's just where regression begins, and that happens sometimes in statistics. So we just add this sentence here just to kind of account for, we know that we're a smart individual, and we know that this really won't happen. You won't have a mixer that's 0 pounds, okay? So sometimes it is meaningful in context, and sometimes it's not. And it will be really clear. You just need to think, could that actually happen? Could I have a baby that's 0 pounds? No. Could I have a mixer that's 0 pounds? No. Okay. Let's go back and let's talk about the slope now. Okay, what is the slope? Go back to your Algebra 1 days. The slope, that's our rise over our run, right? It's our change, right? It's our change in y over our change in x. And what we do in statistics, you guys, right? What we do, so delta y, oops, I have a virus. Delta y, that's our change in y over our change in x. And in statistics, when we're looking at regression, that change of x is always 1 x units. Okay, so you can think of it rise over run like this, or change in y over change of x. What do I mean? As I run, so rise over run, as I run by 1 x unit, so as I increase my weight of my mixer by 1 pound, we rise then, right? Rise over run. So I talked about the run first, that's okay. As I increase the weight of the mixer by 1 pound, what's happening to the cost of the mixer? It's going up by approximately $12.53. So it's rising, running. So as I'm running 1 pound, I'm going up by 1 pound. My cost of my mixer is going up by about $12.53. Let's get that down, something that we can write about, not just talk about. Okay, so I'll give you a template like I did before, and then we'll write it in context. The model suggests that the slope is equal to approximately whatever it is. So this is where you're going to put the value. The value of what? The value of the slope. Oh, because I can spell. Okay, so the model suggests that the slope is approximately, and you put what that value is, tells us the predicted change in y, again in context, when x in context increases by 1 unit. This should be in context as well. Take a second to write this down again, because this is what I'm going to be looking for on a test. This is what the College Board is going to be looking for. Okay, so now let's do it in context of what we're talking about, okay? Oh, yikes. Sorry, guys. What was I doing there? Okay, so the model suggests that the slope is approximately 12.533. So we just word for word what we have right from this template right here. Tells us the predicted change in y. So tells us the predicted change in the price of the mixer. That should be gone. Forgive me. Right? Tells us the predicted change in y. So let me highlight. Again, I'm just following this template. I'm filling things in where I need to. So here, 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 and here. The model suggests that the slope is approximately 12.533. Tells us the predicted change in the price of the mixer. That's y in context. And let me tell you guys, this word predicted is huge. If you don't have that, you'll be docked. When the weight of the mixer increases by 1 pound. So we have the y, now we have the x. When x, the weight of the mixer, increases by 1 unit. Again, we just took this template right here and we filled in the blank where we needed to so it was in context. Okay, now the next thing is, why do we need this least squares regression line? What's the importance? The importance is for prediction. And so with that, we want to do some prediction, okay? Predict the price of a mixer that is 25 pounds and 5 pounds. Let's do that. Okay, you can see that I rewrote the regression line down. And what we know is, we know that this is the weight of the mixer. Okay, so that's our x variable, right? We know one of them is going to be 25 pounds and one of them is going to be 5 pounds. So all we do, guys, is we plug it into that x value. So you can see here in the x value, I know one of my weights is 25 pounds. I just plugged it in, typed it in my calculator, and we'd say, hey, when the weight of a mixer is 25 pounds, we would predict the value to be $292.54. Again, it's all about a prediction. We could do it again with that 5 pounds, again, plugging 5 into x and then just typing into your calculator, okay? Plug and chug. When the weight of a mixer is 5 pounds, we would predict the price to be about $41.94. Again, notice I'm saying things like about or approximately, predicted. There's an issue with one of these though. One of these is a risky prediction. Do you know which one? Let's look back at our data. I want you to notice I gotta move one thing here. Our minimum value of the explanatory variable, okay, the x-axis, the minimum is 8, it looks like. The maximum value of our weight up here, I believe, is 32. This is our domain. It goes from 8 to 32 with our data. The domain of our data goes from 8 to 32. There's values in between 8 and 32. Well, what do you notice about our x values when we were predicting down here? Hopefully you're thinking 5. There's an issue there. If our domain of if our domain went from 8 to 32, we had x values anywhere from 8 to 32. 5 is outside of that domain. Hopefully you're thinking 5 is outside of that domain, okay? That's an issue. When we use a regression line for prediction, we can't use values outside of that domain, okay? We had data from 8 to 32 that we use to build this regression line. If we take values outside of that domain, it's a risky prediction, and that's called extrapolation. Extrapolation is where we're plugging in a value beyond the given domain from the data used for the regression line, and we try to predict. This is a risky prediction and should not be common practice. So instead of actually plugging in 5, I should have stated that 5 is outside of that domain from the data that was used for the regression line. It's a risky prediction and I shouldn't do it. It's extrapolating. Okay, from this lesson, you should have learned how to interpret slope, how to interpret a y-intercept, how to use a regression line for prediction, and to know when it is not okay to use that line for prediction, when we're extrapolating. Write down any questions that you have right now, and let's make sure that we talk about them in class.